Okay, let's jump right into this explainer. Think of this as your ultimate cheat sheet for demystifying the 2025-26 Science Model Question Paper 4, so you can go in and secure those perfect marks. Look, if you've been staring at past papers, scratching your head, wondering what exactly the examiners are looking for, you are absolutely in the right place. We are going to decode the official marking scheme today, straight from the source. We're breaking this dense 28-page grading rubric down into a super strategic study session. We'll start with the overall model paper strategy, and then we'll tackle Section A Physics, Section B Chemistry, and finally, Section C Biology.
All right, first up, cracking the KSCAB marking scheme. What's really fascinating here is that the board isn't just looking for you to dump everything you know onto the page. No, they are hunting for very specific keywords and logical structures.
So, your absolute secret weapon here is show, don't tell. Understanding how to present your answers visually, using the exact phrasing they expect, is literally the guaranteed way to unlock full marks. Think about it. The examiners have hundreds of these papers to grade. If you use diagrams, tables, and really clean bullet points to make their job easier, they're going to reward you for it. Let's look at exactly how to pull that off.
Moving right along to Section A, Physics. Let's dig into some of the highest yield questions and see how to tackle them with total confidence.
Notice these two scenarios dealing with parallel currents. When you're evaluating these, you must explicitly state that the wires will attract each other in scenario 1. Why is that? Well, it's because the electric current is flowing in the exact same direction. The magnetic field around those current-carrying conductors creates a force that literally pulls them together. State the scenario, explain the current's direction, and boom, you get the point.
Building on that kind of logic, let's talk optics with this classic board question. Why is the danger signal always red? Now, you might think you know this one. Maybe you just write, oh, because it travels far. But let's look at how the board actually allocates the marks here.
This perfectly shows how the examiners think. Just stating that the color is red, that secures your first mark. But saying it travels far simply won't cut it for the rest. Explaining that it has the highest wavelength gets you that second mark. And then, this is the kicker, stating the crucial consequence, which is the lack of scattering in fog or smoke, gets you the full 3 marks. You've got to connect that physical property right to the environmental outcome.
Now check out this brilliant illustration of the Tyndall effect and light dispersion. It shows a beam of white light passing through a very specific arrangement of 3 glass prisms, labeled X, Y, and Z. A typical question will ask about the spectrum on the screen and what that final prism is actually doing.
So, if they ask for the role of prism Z, your golden keyword is recombines. It recombines the different color components back into white light. Prism X splits it apart, sure, but Z puts it all back together. Definitely memorize this sequence because these visual setup questions are massive point scores.
Okay, Section B, conquering chemistry. Let's switch gears a bit. When it comes to chemistry, diagrams and super clear comparisons are absolutely your best friends.
For instance, when you're asked about ionic bonding, like the formation of sodium chloride, please don't just write a massive paragraph. Draw this exact electron dot transfer instead. Show that single valence electron moving from sodium to chlorine to form a positive sodium cation and a negative chloride anion. Doing that secures you maximum diagram marks instantly because the visual tells the entire chemical story.
And that exact same rule applies to apparatus diagrams. Take the experiment showing the action of steam on a metal. You need to make sure your diagram perfectly labels the metal sample inside the boiling tube and the delivery tube routing the gas. Why? Because according to the rubric, those are the precise 2 parts the examiner is grading you on. So don't waste time drawing a highly detailed Bunsen burner, just focus on what the rubric actually demands.
And hey, when a question asks for differences, always use a table. Comparing saturated versus unsaturated carbon compounds in a neat little grid like this makes it effortlessly easy for the examiner to give you all 4 marks. You just hit the bonds, the reactivity, the flame color, and the reaction types. Done. Full credit, moving on.
Finally, Section C, beating biology. Detailed processes and heavy-hitting diagrams carry a ton of weight in this section, so let's get into it.
The board really loves testing your logical reasoning with environmental biology. They might throw a question at you like, why does a terrestrial animal breathe slower than an aquatic one? So how do we perfectly answer this without just rambling on?
You take it step by step. The real trick to full credit here is explicitly contrasting the 2 environments. You have to state that water has exceptionally low dissolved oxygen while the atmosphere has abundant oxygen. Because of that stark difference, the aquatic animal literally has to work harder and breathe faster just to meet its basic oxygen needs.
Now check out how they test anatomy through data. They give you animal A with a long intestine and animal B with a short one, and ask you to deduce their diets. The really interesting fact you need to drop here is that meat is actually easier to digest than plant cellulose, and that is exactly why animal B, the carnivore, has a much shorter intestine. Make sense?
Next up, the nervous system. If a question asks what happens when you step on a thorn, they're looking for the reflex arc. Laying out this exact 5-step sequence, starting at the skin receptors, going up the sensory nerve to the spinal cord, and then shooting right back down the motor nerve to the muscle effector, guarantees you full points. It's clean, it's accurate, and it perfectly matches the marking scheme. Now, Mendelian genetics can feel incredibly tricky, I know. But drawing a simple 4x4 Punnett square lets the visual do all the heavy lifting for you. This grid flawlessly explains that 9:3 to 3:1 ratio of round/yellow to wrinkled/green seeds. The examiner sees this grid and knows instantly, without a doubt, that you understand dihybrid inheritance. And finally, for the classic human heart diagram. Whatever you do, don't just label things randomly. Pay close attention to what the board specifically asks for. In this model paper, they strictly wanted the superior vena cava labeled at the top and the left ventricle labeled at the bottom right. Practicing exactly what they ask for is going to save you so much precious time during the actual exam. So what does this all mean for you? By thinking like an examiner, you completely change the game. You're not just memorizing a textbook anymore. You're learning how to communicate complex science as efficiently as possible. Next time you look at a past paper, ask yourself, are you just practicing an answer, or are you practicing the exact visual structure the board is literally begging to see? Go dive into your notes, restructure your thoughts, and go get those perfect scores.